When we're doing water heater service, a couple of key tools that are going to be necessary, of course, your basic channel locks and pliers and screwdrivers, that sort of thing. But the multimeters, your volt-ohm meters, very key to getting accurate diagnosis, therefore making the right parts change if necessary. I've got three different types of meters that you're going to commonly see at a HVAC house, plumber's truck, something like that. But it's important to understand their functionality, which one works best for you. Personally, myself, an auto ranging meter, knowing I can set it to measure resistance, it's going to choose the appropriate scale for me. A meter that I have to select the scale, I need to know what am I looking for. Is it going to be a 200K, a 20K type setting? And then you have your clamp style meters. Some of these may have limitations to maybe 20K, something like that. So knowing what you're testing is very important. That helps you select the appropriate volt-ohm meter, and that's going to lead you to be the best mechanic you can be, diagnosing the part, replacing what's necessary, but know your tools, read the instructions. It helps you go a lot further. In addition to volt-ohm meters, necessary tool for accurate diagnosis of water heaters, we're going to need to use manometer, something to measure vacuums, pressures, that sort of thing. Manometer, we're going to use it on gas. We're going to use it on blower, vacuum, or positive pressures. We have two different styles. The most common styles here, a U-tube manometer, literally shaped in a U fashion. Water or specific gravity oil is going to be in there. And the fluid's going to move relative to the pressure of the vacuum that it's seeing. If it sees a positive pressure, the tube connected to this left-hand side there, as I blow positive pressure into there, you're going to see the fluid actually go downward. Same thing's going to happen if I connect it to a gas source. So, a positive pressure. Now, if this fluid is pulled upward, as if it were a vacuum, say I'm connecting it to a blower, an induced fan, something like that, we would see this fluid come upward. All right, so able to measure positive pressure in a vacuum or a negative. And if I'm going to measure gas pressure right here, we're going to see this fluid push downward. Gas pressure, very necessary. We need to know our basics. Okay, positive gas pressures, you're going to add the numbers together. So if we look at the top side of this, approximately 3.4, 3.5 inches, plus that same type number, 3.4, 3.5, add those two numbers together, we're just about 7 inches of water column, which is an ideal pressure on the incoming side of the gas valve. Now, old school, what I'm going to call old school manometer, relies on gravity, tends to be pretty constant. If I use a digital manometer, we're going to see a very similar number when I plug it in here. Again, showing my positive pressure, 6.89, almost 6.9 inches. So what you're going to see with a digital manometer, a little more accuracy, finer graduation, but you rely on batteries. Okay, you rely on room, atmospheric pressures, things like that. So having both tools in the bag, very beneficial. There's a time and a place, having the right tool to do the job.